Hi, welcome to the Data Analytics project where I'll be presenting the data preparation and models construction. I'll be moving between my Microsoft Word document report as well as the actual SAS minor program itself. So as you can see here, basically what we are trying to accomplish today, our objective is mainly pertaining to ZenBank, which has actually launched a personal loan scheme and is trying to increase the success rate of existing customers taking up the loan. So basically, we'll be going through and using the replacement nodes that explore cluster, segment profile, transform, as well as other decision predictive modeling nodes during this presentation. So the data set that we have in the report is as such, which go through mainly things such as age, ID, like number of experience, annual income, and other factors such as education, mortgage, personal loan, whether the customer has a securities account, has a CD account, using internet banking services, etc., etc. So we made a few assumptions over here whereby the customer's age cannot be 0, number of professional experience cannot be negative, it must be 0 or more, as well as the family size of customers must be between 1 and 4. So our sample set, original data set is as such. And basically for preparation, we actually started with the file import since the data arrived was actually in an Excel format. And we then moved on to actually do some form of stat explore, where we actually explored the various variables inside the data set to ensure that there are no any exceptions noted. And we actually noted some exceptions where there were actually some weird values that were inside or missing values in that sense. And there was a need for us as such to actually do a replacement node in order to actually remove away such exceptions noted. 11 entries in family and education, 12 entries were at question mark value. So we actually did a replacement node under class variables where we replaced them to make them become missing entries. So as you can see, this was the setting that was actually being placed with the replacement node settings over here for further details. After that, we then moved on to do our data partition where we actually selected 70% training, 30% validation. Okay, moving on, we actually did a few predictive models for this particular analysis, which are the following: decision tree, assessment measure decision, assessment measure average squared error, polynomial regression, stepwise default forward and backward, as well as neural network. So for each of the various ones, we actually plotted out as such, whereby over here, after data partition, we actually did the two decision trees, and over here we actually imputed before doing the stepwise regression and neural network before doing a final model comparison. And for each of them, we actually looked at the results where we were looking in terms of the average square error, basically the subtree assessment plot showing the average square error and misclassification rate results for each of the 7 predictive models that were being used. So you can see the report basically that these were the actual screenshots taken from each of the various predictive models. So moving all the way to the bottom, basically what we ended up with was the results for the model comparison, where we actually took a look to see the various the various misclassification rates as well as average square errors of the models before we made a final comparison. And based on the results that were actually generated, the model that actually had the lowest average square error and lowest misclassification rate was the decision tree probabilistics. As such, this will be the model that I've decided that we'll be going for to use in order for the analysis on how to predict an increase in the success rate of existing customers taking up a loan from the bank. So to quickly sum it up, we also did an extra segment profiling over here, which is upon the replacement node, which we actually transform the variables to come up and look at the different kinds of clusters that are available from the data set itself. So at the bottom over here, this section, we talked about segment profiling. We actually had to do transform variables as we noted the skewness of the variables seemed to be a little bit high. As such, there was a need for us to reduce it through the transform using the log method. And basically at the end of the day, what we actually received was 5 clusters, the 5 segments, I beg your pardon. And based on the results for each of the segment, the conclusion is that the marketing efforts will actually can be focused more towards the top 67% of customers coming from segments 2 and 3, which are mainly about customers having lower than average experience and age, as well as customers having higher than average age and experience. So that sums up the report for this particular data set which I have chosen for Zen Bank, and thank you very much.